These little programs that I make for the Royal Tutorial Initiative are all about physics. And on the one hand, physics is everywhere. Physics is up in the forests. Physics is in the trees. Physics is on the mountains. But if we think about old Bhutan, when we had little houses sitting by themselves in the middle of a forest, no roads, the only way of getting from one house to another was by walking. If we think of those days, the amount of physics was slightly limited. Now, since 1961, we have seen a profound changes in Bhutan. And one of those profound changes, which has utterly altered life in rural Bhutan as well as in towns, is the coming of the motor car. And the first motor car came into Bhutan only in 1961, 50 years ago, well within the memory of a lot of people alive today. And the first motor car came into Bhutan. I lived in Bhutan originally in 1971. There were 50 or 60 vehicles in the whole country. Today, there are a few tens of thousands of vehicles. And that's given rise to the workshop. And here I am sitting in Kunga workshop in Thimphu, and I'm wanting to talk about something that came into Bhutan for the very first time with motor vehicles. I can't think of any example of gears in Bhutan before 1961. If anybody can think of any, it'd be very nice if they could tell me. So, motor vehicles came into Bhutan, and with motor vehicles came the thing that I want to talk about today, which is gears. Gears. And I've got beside me here a gear wheel from a truck. Very big, very heavy. I'm going to talk today about gears, what they are, what they do, and why they're useful. And so let's go and look, first of all, at the gearbox of a motor car. And Kunga Workshops have kindly opened up a gearbox for me so that we can see the gears inside it. And then I'm going to talk a bit more about how the gears work.
Our test car has a speedometer, an RPM gauge, an engine that explodes at 200 RPM. Let's push it to its limits. It reached the maximum speed of 16 kilometers per hour in 8 seconds. Can we get better acceleration, better maximum speed? Let's study our engine. The gear attached to it exerts a certain amount of force. This force can lift 20 kilograms, but not 40 kilograms. We will now demonstrate how a few additional gears can enable us to lift 40 kilograms. A visualization trick will help us to choose the right gears. This orange flare represents energy. To be more precise, let's mark the distance our force crosses in 1 second and multiply this by its magnitude. This is our engine's power, the amount of energy it unleashes every second. At this RPM, the power is about 40 watts. Power is transmitted from gear to gear. Assuming no friction, all 40 watts reach the last gear and it exerts the same amount of force. In this arrangement of gears, the last gear's teeth are moving slower. Since energy cannot disappear, our 40 watts will now produce the double amount of force, as gear ratio of 2:1 creates this effect. In our car, the engine's power is transmitted to the back wheels. Each wheel gets half of it. The force exerted by the wheels accelerates the car. Our new car has a 2:1 gear ratio in its gearbox, doubling its acceleration. Let's compare the cars. We'll visualize power, but this time show the amount of energy produced every 1/10 of a second. This is now 400 watts. Eight kilometers per hour in 2 seconds. That's better acceleration, but worse maximum speed. We can rearrange the gears to get the reverse effect. Less force, more speed. Our final car has a gear stick, allowing the driver to switch between low gear as in the second car, medium gear as in the first car, and the new high gear . 16 kilometers per hour in 6.5 seconds. .32 kilometers in 23 seconds.
Gears came in to Bhutan with motor vehicles. There are no gears in prayer wheels or clouds. There are no gears in walking along a track. There are no gears in an animal. Gears are artificial, man-made objects and relatively new to Bhutan. Perhaps that's why people learning to drive, I bet you if you asked a few people learning to drive, the most difficult bit of learning to drive, it's learning to change gear and when to change gear. Let's go and see the gearbox.
This video clip demonstrates how to change the gears using palm away and palm towards. The first thing you do is you press the clutch all the way down to the floor and select first gear by using palm away method, pushing against the stop and up. For doing second gear using palm away method again, and like the picture, you do a straight line down, all the way down to second gear. For third gear, using the palm towards technique, you push it to the middle, which is neutral, and straight up, which is your third gear. For fourth gear, you are doing the palm away in straight line down to fourth gear. So fifth gear, you use palm towards U method. You push it towards the stop and straight up. And when selecting reverse, you bring it back to neutral. There is a button on top on this car. You press the button, drag it all the way away from you and push up. That is for reverse for going backwards.
So here we are in Kunga Workshops. Hello. Now you're Mr. Lasang.
Yes.
Good. And you work here in Kunga Automobiles, I see. Good. Now I'm trying to explain to the viewers a little bit about gearboxes in motor cars.
Okay.
Now everybody knows where the gear lever is, but most people have never really looked inside the gearbox that the lever is connected to. Can you show me a gearbox? Thank you. Thank you. You tell us a little bit about what this is.
This is the gearbox of Maruti car.
So, a Maruti 800 car gearbox. It's quite big, it's quite heavy. and it's very important for the working of the car. Now, the engine of the Maruti will be here, and then in between you have the clutch, and then the power of the engine goes to turn this spindle here in the middle. So the engine turns that. So where does the power come out? Well, the power comes out through here. So what is inside this gearbox? Can you take the top off for us? Here you can see what is inside the gearbox of a Maruti 800 car. Have a look at what happens. The engine turns this, a whole lot of gear wheels in here, all different sizes, and the power goes through the gear wheels to here, turns this, and then the power to run the wheels comes out here. So engine power in and out, and the gear wheels in between do all sorts of things. So that's what's inside the gearbox of your car. And what happens when you change gear? Well, you see this thing here. This moves when you change gear. Won't move at the moment. But this moves, and it moves the gear wheels, so that sometimes some gear wheels are connected, sometimes others are. And this changes gear 1, gear 2, gear 3, gear 4, and reverse, and all that takes place through the meshing together of these gear wheels. So a gearbox is quite complicated. And if your gearbox collapses or your gear wheels break, you can't drive the car. Now, this is a Maruti 800, and I think, Mr. Lausin, over there we have a gearbox of a Hilux. Let's go and quickly see the Hilux gearbox. You see, opening a gearbox is not a simple operation. It's quite complicated. But when we open it, look what we find. You'll notice that compared with the Maruti 800, all these wheels are a bit bigger. But fundamentally, it's the same thing. Gear wheels of different sizes. Now, this is the gearbox of a coaster bus. So this is bigger than a Maruti 800. And of course, all the wheels have got to be bigger, not because a coaster bus goes faster, but because the force from the engine, which comes in here, has to be a much bigger force. So the gear wheels all have to be much stronger, because the forces involved in making a coaster bus accelerate up a hill full of people much bigger than the forces involved with the Maruti 800. But you'll see the principle is exactly the same. Gear wheels of different sizes, which allow you to have first gear, second gear, third gear, reverse, etc. So the gear change mechanism is all down here, and it moves the gear wheels so that different gear wheels engage with each other depending on which gear you're in. So when you're changing gear, remember what's going on in your gearbox. These gear wheels are going around very fast. And when you change gear, you're actually making them move inside the gearbox. That's why you have to change gear carefully. You can't just go boom like that. Otherwise, you hear that terrible noise of a learner driver crashing the gears. And if you crash the gears too severely, as you can imagine, one of these gear wheels may break you've no gearbox and you can't drive the car.
First gear off.
Second. Only back gear.
Back gear.
Only four gear.
Four wheel.
Only five.
Yeah, five.
Only back gear. Only one. Only one, only two, only three, only four, only five. There are the controls.
So every time you change gear, think about what's happening inside the gearbox of your car or truck. Thank you very much indeed. This is the differential of a truck. As you can see, gear wheels much bigger and stronger because the forces involved in making a truck are very much greater. But you see the basic principle, the drive shaft from the engine turns this big wheel, which then has got shafts coming out of the side to go to the road wheels at the back of the truck. So it's the same principle. It allows the two back wheels of the truck to go at different speeds when the truck is turning a corner, the differential gear. What happens when a car goes round a corner? Imagine you're with a friend running around a racetrack. If your friend is on the inside, he doesn't have to run so far. You have got a much bigger distance to run as you go around the corner. It's the same thing with a car. Imagine a car going around a right-hand corner. It's going to turn like this. Now, if you watch, you might be able to see. Think about it. Going around a left-hand corner, the two wheels of the car, the outside wheel has to go further than the inside wheel. So this means as you go round the corner, the outside wheel has to go quicker than the inside wheel because it's further to go. And this is a problem. The two back wheels of a car, when they're going round a corner, one wheel is going quicker than the other. If they were locked together so that they had to go round together all the time, we'd have a big problem. This is trying to go faster than that. And that would cause big strain on the wheels, the mechanisms, on the tires, and it would make the car unstable. So we have to arrange it that when the car goes round the corner, one wheel can go quicker than the other. And we do that through some wonderful, clever gearing called a differential gear. It's called differential because it allows the two wheels to go at different speeds. Now, differential gear for the Maruti 800 is there. This peculiar arrangement of gears, these two here go out to the two back wheels. They make the two back wheels turn, and this clever arrangement means that one wheel can go at a different speed from the other. Now, if we rotate the engine is making this whole thing go round. Both of these are going at the same speed, so they're driving the back wheels at the same speed. However, if you would be kind enough to be the engine and turn that, watch what happens if I stop one of the back wheels. If I stop it, the other one continues, thanks to this clever gear mechanism called the differential. If I stop this one continues. So, thanks to the differential, the two back wheels can go at different speeds. Normally, if they're both free to move, they go at the same speed. Keep turning, and you'll see they're trying to pull my fingers round, but if one of them wants to go a bit faster, it can. Both the same speed, and you'll see, keep going, they're both the same speed. That gear wheel isn't moving, but keep going. If one of them slows down, that starts to move, and it allows this to slow down compared to this. So a differential is a very, very clever gear mechanism.
When the troop goes around a corner, the riders on the outside of the corner have to adjust their speed to keep even with the riders on the inside. The man on the outside have to ride a lot further and a lot faster in order to keep up with the parade. The outside wheels must spin faster than the wheels on the inside because they have a greater distance to travel in the same length of time. When a wagon turns a corner, the wheels can travel at different speed because each wheel can turn freely on the axles. And on the early automobiles, the rear wheels turned separately and only one wheel was connected to the engine. But when only one wheel was driven by the engine, it had to do all the work and it couldn't get good enough grip on the road to do its job properly. So, the one-wheel drive was soon out of date. But if two wheels are locked on an axle so that they are not free to turn separately, one or the other has to slide. So the engineers have to find a way to connect both rear wheels to the engine without sliding and slipping on turns. The device which makes this possible is a part of the rear axle. It is called the differential because it can drive the rear wheels at different speeds. The differential looks complicated, but once we understand its principle, it is amazingly simple. These two wheels are mounted on separate axles and supported by a frame so that they can revolve freely at different speed. Let's fasten a spoke on the either end of each axle so that by turning the spokes, we can turn each wheel separately. With the bar or cross piece, we can turn both wheels in the same directions at the same rate of speed. Let's get something to hold this bar in place so that it will press against the spokes. Notice that this support is not locked to the axle, it turns freely. Now we can spin the wheels by rotating the support. This is fine as long as both wheels are able to turn at the same speed. But let's see what happens when we go around the corner. With this arrangement, we cannot drive one wheel faster than the other. And if we stop one wheel, the other wheel won't budge. Let's put this bar on a pivot so that it can swing in either direction. Now, the bar can turn both wheels at the same speed, and because it pivots, it lets one wheel turn even when the other has stopped. But if turned too far, the bar will swing around until it won't drive the spokes that turn either wheels. We need another crossbar and more spokes to carry on the job. When we stop one wheel, the crossbars will continue to push the spokes of the free wheel around. As long as both wheels are free to turn, the bars do not swing on their pivot and the wheels move at the same speed. Now we have the working principles of a differential. To adapt the model of use on an automobile, we will have to make few changes. In order to reduce the jerky action caused by wide spaces between the spokes, we will put in more spokes. Further, filling in the spaces between the spokes give steadier and more continuous action, and changing the shape gives firm and constant contact. Now we can make gears thicker and stronger, and we have differential gears. The edges are cut so that they will fit together more smoothly and silently, and another gear is added to share the work of driving the axles. The principle is the same. In order to turn the support and drive the wheels, we can fasten a large gear here, connected by a smaller gear to a source of power. Notice that the power is connected to the differential at the central line. We can make our model more compact by moving the gears closer together. When we put our differential in an automobile, we have to leave room for the drive shaft, which carries the power from the engine. We may build the floor of the car above the drive shaft, but if we do, we won't have much room inside unless we make the top of the car higher too. Of course, we can lower the floor and ceiling, but the drive shaft will be higher than the floor. This would have disadvantages. A shaft in the middle of the floor of an automobile would be inconvenient for the passengers and would be awkward for carrying luggage. Today, engineers have found a way to make the car spacious, closer to the road without the clumsy shaft above the floor. The drive shaft from the engine to the differential is lowered out of the way, and the drive shaft is connected to the rear axle at the bottom. The new low center drive makes the rear axle quieter, stronger and more durable because it gives better, smoother contact between the gears. The automobile of today with the low center drive is stronger and more rugged. Every part of the rear axle has been built to withstand strains far greater than it will ever meet on the straighter way or around the corner.
The last little piece of gearing in a motor car that I'd like to talk about is the steering gear. Because if you think about it, you've got a steering wheel here, which you turn like that, but the front wheels go like that. So how do we turn this movement into that movement? And the answer is using a particular type of gear called a rack and pinion. Now, here's the steering gear mechanism of a motor car. When I turn the steering wheel, I'm turning a shaft which turns this here. And it goes into a gear system here, and these two arms are connected to the front wheels, and they move like that, left to right, so turning the front wheels. So a motion like this is turned into a movement like that. Through a rack and pinion gear, we can't open this, but the nearest I can show you a rack and pinion gear is my bottle opener from home. And if we notice, we've got a straight gear here. It's not a wheel, it's just a straight piece of gear, and that's inside here. And then we have a gear wheel here. And as this turns, it locks into here and pushes this out or in, left to right. So if you imagine that this gear wheel here comes from my steering wheel, and as it turns, it pushes the pinion, the rack, this way and that way inside here. So this is what's happening in the steering mechanism, the steering gear of a motor car. It's called a rack and pinion gear and is used in all sorts of other applications. But that's how it works to steer your car. So I think we've looked enough at gears in the workshops.